What is laminar flow? I want to write down a few characteristics of laminar flow. So I'm going to write down laminar flow up here. Okay. I think the first characteristic I want to say is I think of it as like a steady flow, like fluid flowing through a pipe and it's just moving kind of linearly through that pipe. So maybe I could say steady. Actually, linear does not necessarily apply to every, because you know, like if the pipe widens or narrows, it's not necessarily in straight lines. It doesn't have to be. I also want to say that there are well-defined flow lines. So I'm going to write that down. Well-defined flow lines. For some reason, I want to make that D look better. Well-defined flow lines, I said. In other words, you can kind of describe like a topology of laminar flow. It's not really exactly a topology, but you can draw lines that at each point in space where there is a line, it kind of gives you an indication of what direction the flow is there. Another way of thinking about it is when you draw a bunch of flow lines, if you ask how does one particular piece of the fluid or part of the fluid move, it will flow along one of those flow lines. And so in that sense, drawing some of them, you can never really draw all of them, because you may as well then draw a line so close together the whole screen or the whole paper would be black if you're using ink, or maybe if you're using chalk it would be yellow or white or something. But it doesn't make sense to draw all the flow lines in that sense. But you have some representative ones and they're well defined, and that's not necessarily the case for all kinds of fluid flow. Some fluid flow is more chaotic, and that's the other kind we're going to look at. The key thing here, though, when I said steady and there are well defined flow lines, is we can describe the velocity field. In other words, if we think about velocity, and maybe I'll say as a vector at each point in space. So if we're working like in a Cartesian coordinate system, you could say as a function of x, y, z in up to 3 dimensions. You take some of those away if you're working in less than 3 dimensions for whatever reason. But at each point in space, it will be equal to a constant. Now that doesn't necessarily mean, though, that laminar flow requires that the fluid's flow or the flow speed is constant everywhere. As the fluid flows through whatever region this is occurring in, and flows along in that sense a flow line, it could speed up or slow down. And in that sense, the fluid is always moving. It's really just the pattern of the flow that remains constant, and in that sense can be described as static. So I'm going to put that word up here and say this is like a, so I'm going to say steady. I'm going to add static up here and say this is like a steady static flow. But keep in mind the fluid itself is moving. So when we say static, it's not like there's nothing moving. It's just always moving in the same way with the same distribution in space. Let's look at the answer here, which is not listed in a nice bulleted way here, but I think it will say similar things. It says laminar flow describes a steady flow of fluid. Laminar flow can be described by static flow lines and have the characteristic that the flow rate as a function of position in space is constant in time. That is, at each point in space, the fluid always moves with constant velocity. Keep in mind in that this is a sentence that I sometimes worry could be misinterpreted, because it says at each point in space. We're not talking about like if you were tracking some like piece of the fluid, like maybe one droplet of water in a brook or something like that. I don't know if a brook is the best example, but like maybe droplet of water in a pipe or something like that. It could speed up or slow down as the pipe, say, narrowed or widened, and yet still be in laminar flow. But at each point in space where fluid is flowing past, at that point, you can always associate that constant velocity.